Hi, it's Kenny from shop3d.ca. Welcome to our webinar. We're doing the Formlabs Form 4L large format SLA printer. And today we're going to go through the overview of the printer, how to use it, product specifications, and we'll even have an applications engineer from Formlabs to tell you how they designed this printer. So let's dive in.
Hi everyone, I'm Pooja from Shop3D. So today I'm excited to give you an overview on Formlabs' recently launched Form 4L. Form 4L is advanced and large format masked stereolithography resin printer from Formlabs. It basically uses liquid photopolymer, or also known as resin, and also uses powerful light processing unit to print and stunning high detail prints. So let's do the quick comparison between the Formlabs printers. Form 4L has a build volume of 13.9 by 7.7 by 13.8 inches, which is 4.6 times bigger than Form 4 and 1.2 times bigger than Form 3L. And when it compared to the speed, it is 2.4 times faster than 3L. Due to high speed and ability to print large volume and bigger parts, several components in the Form 4 has been redesigned and re-engineered. First one is backlight and light processing unit, which is now capable of printing thousands of layers of line. They redesigned the resin tank. Now it is more focused on durability and high performance. With the new resin tank, it can be able to print 75,000 layers, approximately 1 to 2 years of life. So now let's get into the printer and see the sensors. First one, they have the Z-axis force sensor, which is placed over here, which can actually control the peel and squish cycles. Second one is the mixer, where it has the force sensor and can control the resin and any checks for any debris in it. There are resin level sensors, which actually determines the resin temperature as well as the amount of the resin in the tank. Lastly, it has the high definition camera, which is placed over here, can capture the prints after the printing has been completed and also can capture the whole time-lapse video of the printing. So this was the basic overview of Form 4L. Up next is Michael, who's going to be presenting a practical demo on Form 4L.
Hey, this is Michael, and I'm going to show you how to get the print started on the Formlabs Form 4L. And to do that, we'll just start by going into my screen. So here I have Preform open. So we'll first want to make sure that we have the printer selected and that we have the correct resin selected as well. So in this case, it's Clear V5. We can adjust other settings such as layer thickness, but we're just good with the default. From there, the model. So here we have a piece used for thermoforming. Although it's not oriented the direction you'd want it to be, as Preform processes the model, we'll see a bunch of errors, including cupping and other issues. So that means that we'll want to reorientate the model to avoid these issues. So either you can use the one-click, which will generate supports and orient it automatically, or in this case, we just want to orient it ourselves. So we will rotate the model. Just at a 45-degree angle should be fine. So that will mean, one of the things we want to avoid is this flat base on the back being printed directly on the base of the printer. So now that we have it angled, we can generate supports for the model. In this case, we will just use the auto-generate feature. This will take some time. So actually, we've got it ahead and it's pre-supported or done the support ahead of time. Oops. Open that up. So you can see here, the model is plenty supported, but it also has supports on the inside. Because we want to get these details in the thermoforming, we want to remove them. So I want to edit it. Just from experience, we know that this won't have a huge impact on the print, but if you are unsure, it's always better to leave these in place. So just clicking each of these green dots to remove supports from the inside of the model. And going back and clicking the ones I missed. There we go. We'll click apply. And we can see the supports have been removed from the inside of the feature there. One thing you can also do afterwards is just scrub through and check how the print will go. If you want, you can analyze everything and make sure it looks good for printing. Once that's ready, you'll also want to make sure that the printer is ready. So here you can see that the cartridges are missing. So you'll want to make sure that you have the resin cartridges inserted into the printer, as well as anything else, such as the resin tank and the build platform. So before we start on the printer here, we'll want to insert the build platform, everything else, and the resin cartridges. The build tank, the resin tank is ready to go. After that, we can upload it to the queue. And then once it's been uploaded, either start it from Preform itself or head over to the printer and start it on the main screen. That's everything you need to get started. Next is a video from Formlabs.
Introducing Form 4 and Form 4L. Accelerate the way you work. With 3D printing technology that's blazing fast. And ideal for solving any problem, regardless of size. Keep your production running with an unmatched print success rate, built on reliable hardware that was engineered for years of use. To use your time most efficiently, leverage a workflow anyone can learn in 15 minutes, featuring instant material changes, comprehensive software, and automated post-processing. Produce stunning parts that rival injection molding and always fit. With 50-micron pixels, advanced pixel smoothing, and light touch supports. Tackle any problem with our ever-expanding range of high-performance resins, or opt for open material mode to use any resin. And customize your print performance with Print Settings Editor. Built on our next-generation low-force display print engine, featuring a high-power backlight unit, light processing unit, proprietary release texture, and a flexible film tank. Form 4 and Form 4L deliver extreme speed, reliability, and print quality at any scale. A new era of industrial 3D printing.
Welcome back. We now have the parts that we were slicing earlier printed. These are printed out of Formlabs standard clear resin, and as I mentioned earlier, are going to be used for thermoforming. What thermoforming is a method that will take a sheet of plastic and heat it up so that it can be shaped to the form of our part. In this case, a more ideal resin would be Formlabs high temperature resin because these plastic sheets are being heated up to a high temperature. But something like standard clear resin will work for a few parts. Another thing about thermoforming is that it's great for small batch production. For example, these parts were made on the Mayhew multiplier, which is a vacuum former, pressure former rather, and it will allow you to make multiple copies of a part like this or anything else that you would like to 3D print. One thing to take into consideration when doing 3D prints for thermoforming and pressure forming is that you'll need a place for the air to escape. So you can see there's a lot of holes on the back here. That way, when the pressure is forming the material to the mold here, that it doesn't trap any air and give us undesirable results. The precision that the Form 4L offers makes it very easy to get precise details like those small holes that I was talking about. That's enough from me. I've been Michael. Next, we'll go to a special guest from Formlabs.
Hey guys, it's Ken here, and I have a special guest with me. I actually have Chris Lee from Formlabs, who is their Senior Applications Engineer, and he wanted to tell you something about the Formlabs perspective of the new Form 4L. Really excited to hear from Chris. Chris, please introduce yourself and take it away.
Great. Thanks, Ken, for the introduction. My name's Chris. I'm on the sales engineering team here at Formlabs. Over the next 20 minutes, I'll take you through a deeper dive into the design and creation of our latest and greatest SLA machine, the 4L. So generally, to show off what's the latest and greatest, we do need to take a step back. So back in 2012, Formlabs entered the market, a normally inaccessible market to normal consumers. And with this, we positioned ourselves in between the two ends of the spectrum. One end of the spectrum is going to be the low cost, often unreliable, and sometimes unsafe printers. On the far side, we have the high performance, high throughput, but often inaccessible due to the required workflows or financial stabilities there. With Formlabs, we have the industrial quality, reliability, built-in systems for support and upkeep, but at a fraction of the cost so that anyone from a mom and pop shop to students to anyone can utilize this printer and have it work. Obviously, it's been quite a while since we founded the company in 2012. Since then, we've released from the Form 1 to the Form 2, Form 3, and now the Form 4 in a small format and large format system. In that time, we have done quite a bit of selling, quite a bit of printers shipped, and with those printers shipped, a large number of parts. So the two that I like to focus on here is over 130,000 printers being shipped. So when it comes to professional SLA 3D printers, we do have the largest install base, and this is also going to be the same for our SLS ecosystem. And with those printers and the 40 plus materials available, they are able to produce over 300 million parts, which is a crazy number. And then another piece that I'll mention is the 300 plus engineers and scientists for similar companies in the same realm as Formlabs. We do spend the most amount of money in terms of R&D and planning for the future and our future products. We are also a global company with factories all across the globe and offices anywhere from Boston, which is where our headquarters is at, to Singapore, Budapest, and even Berlin. So focus today is going to be the 4L and the Form 4. With the 4L, it is going to be our largest SLA 3D printer, 14 by 8 by 14 inches tall. With that, we are getting obviously the big parts, but with big parts, you want to be concerned about the time it takes to produce each part. With our new technology, which I'll get into later, we are able to do large parts in under 6 hours, unmatched success rate, versatility in the form of open material platform, and our own resin that we are producing ourselves, and we have the quality to match. Form 4, again, that's been out a little bit longer. At its core, it's going to be the same base technology, but on a smaller scale based off of your part size needs or applications or whatever it may be. So we'll take a deeper dive into what Formlabs values when it creates products and what separates us from similarly priced competitors. First item is going to be versatile. Versatility comes from the amount of materials and what those materials can do. When I talk to customers, most customers don't really care too much about the printer specs, the printer size, and things like that. Most customers care about parts. Parts are what you produce, parts are what you sell, parts are what you use in your day-to-day life to solve your problems. With the materials here, we can fit and solve as many problems as possible, whether it's from your general purpose, form, fit, and function pieces to durable pieces that require high mechanical loads or higher HDTs, like our Rigid 10K, getting into some specialty resins like the ESD, flame retardant, or even our true silicone material in a 40A, and then even different markets like the dental and medical spaces. Formlabs does all of our own chemical composition and makeup in our chemical lab in Boston, and then all of it is manufactured in a facility out in Ohio. So a normal...
Now, Chris, do you have a personal favorite that you like to print with the most?
Yeah, so I do enjoy the fast model. Fast model is something that I can do very, very quickly. If I'm trying to make a helmet or a bottle, whatever it is, I can still get the same base quality as our general purpose, but I'm doing 200 micron layer heights, and they can get done in just a few hours, even for the largest pieces.
Yes, incredible composition.
And on that point of domestically manufactured resins, because we're doing it in the US, we do have higher levels of safety control and levels in which we need to adhere. So the normal stigma behind cheap resin printers is that the materials are stinky and dangerous. With Formlabs, we don't have that because they are manufactured in the US. If for whatever reason customers cannot find an appropriate material available already, Formlabs has recently opened up the ecosystem to work with open material mode. So that means any third-party resin that is in the same general range of wavelength can run on the Formlabs ecosystem. You can adjust the settings we have already for our materials via the print settings editor. And then we are working with partners more directly for certified third-party materials to where we'll make the settings, you buy the material, and then run it on the printers. Next design principle is reliability. The main separator between us and the low-cost 3D printers is going to be how much time do you want to put in to calibrate your printer when you first set it up, to continually updating and upgrading, things like that on your own. Formlabs' perspective is always going to be, we want it to be as reliable as possible. Customers shouldn't think about how much time needs to get put in to get the right parts. They just need the parts right away and have the machine itself do all of the heavy lifting. With the reliability, you are able to get higher levels of utilization. If you are a dental office needing to make a couple hundred dental arches in a day, you can't do that with many other 3D printers in our price range, and even larger parts as well. Large parts get exponentially more tricky, especially the more supports and things like that. But with the 4L, we're able to dial in settings that we've created ourselves that the customer can utilize from day zero to just click print and have it work effectively. And then over time, we do have a very strong support team, services team based in the Boston area, Milwaukee area, and globally, and anywhere else, obviously through the reseller as well, to maintain, if anything may go wrong, we will have the solution in place to get whatever it is swapped out or ready to run very, very quickly. And then jumping ahead here, the last design principle is going to be the ease of use. There are methodologies in our preform software as well as our general hardware to have it be that you can just click one button and get the material oriented, support generated, sent off to the printer, and if that printer is then primed, it will start automatically. What that allows for is less downtime or changeover between materials, and in conjunction with the faster speeds and throughput, we can get 5, 6, 10 different iterations on a single model within the same day. Other systems, it's much harder to do. And one other note I'll make on the preform side, outside of the one-click printing, is even if you forget to add part labeling, or if you want certain textures, things like that, we are building more of those features into preform as well, to where it's a more self-enclosed system where everything can get done within one software, as opposed to jumping back and forth between the slicer software and your CAD software. Post-processing is another feature that we focus heavily on to reduce the amount of labor involved and also reduce the amount of possible spillage or wasted resin or wasted material, whatever it may be. So we do have the full ecosystem, obviously the printer via the Form 4 or Form 4L, and then we do have the small format and large format wash and cure. And then most recently, we announced and released the Formlabs resin washing solution, which is a non-flammable cleaning solvent that could be used instead of IPA or TPM. Okay, so now a little bit more into the nitty-gritty print engine and technology itself. I believe next slide is a little video that we'll go through. and then we'll go to a more low-tech version of it, but it does go slower, so I can walk through the entire process. So we call this the stack. The stack has been basically designed from the ground up from the Formlabs team. It is custom to us, and what that allows us to do is maximize the print throughput in conjunction with high levels of accuracy.
Yeah, Chris, I don't know if you can tell us this, but how long did you guys spend on building this new light engine?
So you notice on the timeline at the start, it was roughly 22 when the latest Form 3 Plus came out, and then it was 2024 for the latest Form 4. I will say that even while the Form 3 Plus was going to market, there were still engineering teams starting or going through the process of dialing in, do we want to do this type of technology or something else? So it's been quite an endeavor to get where we're at.
Yeah, I'm sure there was a lot of back and forth in what technology we should go with. So I think it's really amazing the amount of power that this puts out. It certainly puts to shame a lot of those hobbyist printers, and it's completely in a league of its own.
Mm-hmm. So, I mean, I will say we aren't the first company to come to market with this technology, but when we combine all the core components and the software and materials, I think we're second to none when it comes to the throughput and the material capabilities.
Absolutely.
So just a quick run through the stack here. So the backlight unit on the very, very bottom there, that is producing the high-powered LED light, high-powered as in like industry-leading high-powered LED light. What that LED light goes through is a lens array. That lens array collimates the light. Collimates just means that it's going to be in a even playing ground. Basically, there's no hot spots or cold spots. So whether you're printing directly on the edge or in the middle, you won't see any loss of quality or mechanical properties. Once that collimated light goes through the lens array, it then goes through our LPU4. The LPU4 is our masking agent. Obviously, we need to have some control over the shape and the object that we want to print. So you can imagine on a screen, looking at the bottom left there, is essentially a grid of pixels. We then send electrical signals to each pixel saying, do I want light to go through or do I want light to stop at this point? As we send those electrical signals, it is creating a image, whether it's 1 part or 50 parts of your individual layer. We are also including anti-aliasing, which is a smoothing process for these parts, and we're taking a screenshot of each layer. We're doing that a couple hundred, couple thousand times, depending on the size of your part. And as the screenshots and as that individual layer is cured, you are then releasing the build platform from the tank and the tank film, and that would make sure that the parts obviously come off and do not stick in the tank. And you see here the backlight unit with the little bubbles. They look like bubble wrap on the top left, the LPU4, which is the masking agent, on the bottom left, and then we have a tank assembly on the right, and that black cover is just a UV cover that we have to prevent any UV exposure so we can keep the resin inside of the tank and keep them stored in a relatively cool and dark area. Another example here of the printing process. So we're doing a full build area. You'll notice that the resin is inside the tank and then the mixer is on the left. What that mixer is able to do is, as the printer is running, it will agitate the material, making sure that there's no settling and the material is in the proper conditions to cure effectively from layer 1 versus layer 1000. Okay. In order to get where we were with the Form 4 and the Form 4L, it's one of those things where it takes 5, 10, 15 different iterations to get something right. A seemingly simple task of having the proper latch of that mixer to the belt-driven actuator underneath seems like a simple enough task, but when you are concerned about the control over the acceleration and lack of vibration and things like that, it turns into a much larger and longer problem to solve. Something that we have many engineers working through and making sure we can get the best possible solution for both the costing, so we can get the printer as cheaply as possible, and also we want to make sure the reliability is there such that customers aren't having to replace objects or pieces at a more frequent rate. So picture on the right is some different versions that were worked through. Obviously they look similar enough, but they're not going to be the exact mixer assembly that we have on all of our printers today. This is another important engineering task that had to get figured out. So this was a major upgrade for those that have worked with the Form 3 different cartridges. So the Form 3 cartridge is on the bottom left there, and the Form 4 cartridge is on the top there. What we were trying to do was, I guess, two main factors. One, we wanted to reduce the amount of plastic waste that customers are producing with the Form 3 cartridges. That came in the form of a sleeker design, less plastic being used, and we also wanted the cartridges to dispense a lot faster. Form 3 cartridges, you usually have to wait a few minutes for a tank to get filled up, where nowadays a clear material or a GP material can get filled in a tank in basically seconds on a Form 4 or even the Form 4L tank. So what they're set up here is in the middle, it's testing for the 0.01% of errors. It's taking these cartridges and basically dispensing them out into another cartridge so that bottom row can then get swapped out. Then that will go back into the other one, and this is a continuous process so we can get as many iterations as possible on these cartridges without having to send out a couple hundred cartridges to customers. We can do all of this in-house, see exactly what can go wrong after 10, 100, 1,000 hours, see if any engineering changes need to be made, and continue until we get to the proper rate of a failure, which for us was the 0.01%. And with that, we do have as I mentioned earlier, the sleeker design for the cartridge, a slightly different bite valve. So that is the rubber piece that is getting squished on the right. And what that will do is allow for better flow of that resin, and the way it closes as well will reduce any extra little drippage or spillage. And with a 3D printing company, most of our jigs and fixtures are also 3D printed. So you can see, I think it's maybe a TUF 2000 or TUF 1800 that's being assembled together to work through that process there. So Formlabs has always been as easy to use as possible, similar to like the iPhone versus Android conversation that consumers have on the phone industry. I would say we're a little bit of both, in that we take known items, chips, processors. We even have a Raspberry Pi doing most of the work on the processing side, items that we know will work very well, so we can spend a lot more engineering time on things that we need to innovate on. That's meaning the backlight unit, the stack, and some of the other sensors like the resin level sensing and some other things like that. That also, lives here with the custom PCBs and some things like that we know we can't afford to rely on third-party objects for. And so with this, we can have full control over what we want to spend our time on versus what we want to just get off the shelf. Another piece that I would say we are a little bit better on compared to the iPhones would be the serviceability. Usually with iPhones, if you need to get your battery replaced or your screen or whatever it is, you have to take it down to the Apple Store, get it shipped out, and it takes maybe a couple of days, and that's not what you want to do, especially for customers that are needing the high level of production and things like that. With the Form 4 and the Form 4L, everything that you need to service the printer is actually in a little 3D printed caddy that comes with each printer. It's shims to adjust the bed level, and then it's a handful of Allen keys. So the backlight unit, the LPU, anything major that would need to get replaced over extended periods of usage takes all of 5 or 10 minutes to swap out, a couple of hex keys, and you're done. So now jumping over to some industries and applications. 3D printing obviously has been around for quite a while, so hitting most of the major applications here, from manufacturing to aerospace to medical care and even art and design. Formlabs, we've always positioned ourselves to whether we're working with a hospital that needs biocomp testing, or the DoD that needs, COC, COC, or COA batch data to make sure they know what they're getting. We have all of that. That helps us separate ourselves from other 3D printers out there, and makes our custom interactions that much more efficient. And we're able to get, say, FDA approval for some processes, or trying to work our way into the aerospace applications, sending parts to NASA. We've done that in the past, sending parts up into space. We're very proud of, and we need not just the printer and the materials, but we need the entire workflow and ecosystem to create our supply chains and things like that. I will highlight on one specific application that I think is always super, super cool. So these are the next generation air taxis. So think of I don't know if it's AI driven, but it is going to be the driverless, pilotless air vehicles that anyone can basically use. And what this company, Archer Aviation, is doing is utilizing the 4L for rapid prototyping of a lot of their internal covers. And then for things that are a little bit too small, they can do some jigs and fixtures to help out with their manufacturing processes. So one quote I pulled from the customer with the 4L, we're obviously focusing on speed. And this year is just calling out a dig slightly to FDM. So FDM, it does have slightly slower speeds at times, and then you are also concerned about the isotropic nature, the XYZ strength, and also the part quality. Now, that example there was for large pieces, but that kind of brings up the conversation of, well, do you only get the 4L for large pieces, or can you do small pieces? When it comes to the base technology and the accuracy, reliability, things like that, the Form 4L and the Form 4 are essentially the same. Relatively same pixel size, and you can adjust, part geometries and things like that for both. What I always look for as a sales engineer when I talk to customers is, what do you care about most? Do you care about the amount of changeovers that you are doing? Do you care about redundancy? Redundancy, I mean, well, if you only have one 4L, yes, you can print more in one go, but if you want parts every hour as opposed to every 2 hours, something like that, well, then it might be more beneficial to run 2 of the Form 4s. If we compare the throughput of 2 Form 4s versus 1 4L, I will say the 2 Form 4s will just very slightly edge out the Form 4L, mainly due to the larger tank. As you can imagine, when you're utilizing much larger build areas and tanks, it does take a little bit more time for the resin to settle after each layer, and the curing as well, especially if we're doing larger layer heights. That curing time per layer will be a little bit longer than what it is on the Form 4. So I would say the best option is to have a little bit of both. It's still going to utilize the same software, the same material cartridges and things like that. Obviously, it's up to the end use of the customer. So with all that being said, I hope that was a good look into the Formlabs way and kind of where we've been and where we're continuing to grow. I want to thank you all for your time, and I think I will kick it back to Ken.
Thanks so much, Chris. I do have a couple of follow-up questions for you, if possible. For Archer, do you know, if they've expanded their fleet to multiple printers? What are they running now? Now that they've had their 4L and maybe they're adding more to their fleet, do they have a Fuse as well? What are they running in terms of printers?
Yeah, I think at this point they are utilizing the single 4L. I think if it printed a little bit slower, they might need some extra systems to accommodate for that. But so far, the 4L has been printing well, and I
Awesome.
think they're going to stick with it. I will say if they do decide to go, you know, more serial production or something that needs to last extreme levels of UV resistivity and things like that, then we could obviously turn them towards the diffuser monitor or something.
Amazing. And do you know what materials they're primarily prototyping with?
Currently, just the GP, so that is the black V5. The black V5 is a recent, iteration we made on the Form 4 ecosystem. So previously, our general purpose resins were similar to an acrylic. With the Form 4 and the new technology, we took the opportunity to reformulate our general purpose resins. So between the extra levels of strength and resistivity, we're actually reducing the cost of all of the GP resins by, I think, almost half compared to the Form 3 versions.
Yeah, absolutely. We love our V5 resins. Black and clear specifically are really fantastic in V5, and the lower cost is applauded by almost all of our customers across the board. Final question for you, Chris, and then I'll let you go. But in terms of Formlabs and the Form 4L, what's the coolest thing you guys have printed over there?
I wouldn't call it cool, but I would call it satisfying and gratifying. We, at our most recent user summit, had imagine like those rage rooms. You would go out, wear the helmets, wear the glasses. Instead of using a baseball bat, they actually had a durable axe that we basically split 2x4s all day, obviously wearing proper glasses and then things like that. And then we also had some hammers and some 3D printed nails and things like that. So it definitely put the tough and durable section up to the test, and it definitely paid off well and was able to let off a little bit of steam for some of our engineers and things like that. So that was fun.
That's totally awesome. Well, Chris, thank you so much for joining us and providing all of your insight and the Formlabs perspective on their new Form 4L printer. Now, we'll go back to the team. Thanks so much.
Hey guys, my name is Shaw. Thank you for joining me. I'm going to talk a little bit about best practices when it comes to using the Form 4L. To start, I'll talk a little bit about the setup and some of the things to look for. So, what I like to tell users is generally what we want to do is when the Form 4L is empty, to load it up, we always want to load the resin tank first. And so right now this resin tank is empty, but imagine that it's filled with resin. What I like to do is take a look underneath it to see if there's any sort of tiny bubbles on the bottom of the resin tank before I place it inside the printer, okay? Now this one's brand new, so I know there's barely any issues, but as you sort of use them, you will see little dimples on the bottom of the resin film, and it's a good idea to look out for that. So with that said, I'm going to place it in. The first thing you'll notice is I'm placing the resin tank in before I place the build plate. There is a reason to this madness. That is that in case there's any sort of residue on the build plate, we don't want it hanging over the LPU without something blocking the way. The next thing is to put in the wiper. So if there is resin in the resin tank, what I like to do is actually use the wiper to sort of mix the mixture up just a little bit and then lock in the wiper. I do recommend to clean the wiper of the previous resin before attaching it to the printer. The last thing to do is going to be placing the build plate. The build plate sometimes might have little bits of residue on it, so what I recommend is spray it down with some IPA 99%. Spray it on the surface, use a little bit of paper towel to clean the surface before I place it into the printer. You do want to make sure that there is no cured resin on the build plate surface before placing it into the printer. Next, I'm going to talk a little bit about slicing and how to prepare the model to be sent over onto the Form 4. So you can see I have a couple of models here loaded in already. So the purpose of these models is what I want to show you guys is like, one of the things I look out for when I'm loading in models for 3D printing with the Formlabs printer is like, what surface will I generally want the support contact points to be on, okay? Because there's a couple of things I want to consider here when I'm looking at a model. So for resin 3D printing or MSLA on the Form 4L, there's a couple of things that I'm specifically looking for in the model. So how do I minimize? So one is, how do I minimize the cross-section surface area of a model along the z-axis? So that's going to minimize the amount of force acted on the printed part. The next thing is going to be, what is the surface that I least care about the surface quality? Because wherever there are supports, there's going to be contact points. They will show up on the final print as small little dimples. And so if there's a surface that is a critical feature on the print, I don't want supports on that side. So I want to mitigate the supports on the important feature side and place them somewhere where they're less important, or it's very flat, so it's easy to sand off in the post-processing. Okay, so I have two different models here that you're going to see. I have sort of a statue of Captain America, and down here we have some basically lead screw cleaning tools. Okay, so for the instance of the lead screw cleaning tools, the most important area is actually where the threads are, as indicated in here. And so this is why I have them oriented facing almost diagonally up. And this does two things in this orientation. One, it minimizes the cross-section of surface area as well as the overhang angle on where these threads are. And two, because of the way they're oriented, the supports is going to come from the build plate. So it's never going to interfere with that section. And let me show you that in this demonstration here. So I'm going to generate auto supports for these two models down here. And you're going to see the supports are going to be on the not so important surface area, leaving the area where it has critical features perfectly sort of untouched with supports. And so I know once the print is done, once I remove these supports, I don't really have to do too much cleanup for the surface that is important. Now, at the same time, you're going to see this Captain America statue here, right? So what I want to do is I want to put it on an angle, so that way I know where the supports are going to generate. It's going to be along these flat surface areas and not so much in the areas where it's critical, for example, like the front area. So again, I'm going to auto-generate. I'm going to select the model and auto-generate. So while it's sort of doing this, I'll talk a little bit about it. So basically the idea here is to help you quickly set up supports, quickly orient the part so that you have minimal post-processing once the print is complete in the printer, and we move on to form wash and then form cure. Okay. You can see the support has been generated on Captain America's statue over here. Now there are still some overhangs, and with a little bit more sort of tweak and orientation, I can probably eliminate some of these excess support points. But for the sake of the demonstration, I'm going to make it relatively short for you guys. You can see majority of the support contact points are going to be on the flat surface areas, which is ideally what we're looking for, and that's going to really help. So the next thing I'm going to talk about, I'm going to erase all these models here, and I'm going to bring in something that a lot of people know is sort of a bane in resin 3D printing, and that is cupping. So you're going to see here I have a terrible shape in terms for resin 3D printing, and it's basically a T-bowl here. And what I'm going to do is, what I want to do is be able to print this on the Form 4L. And the first thing I'm going to do is actually, you want to reverse the bowl so that the opening of the bowl is onto the build plate. Okay, so this is one of the strategies to print models that have large cupping sections. And what I'm going to do is, with this bowl facing towards the build plate, the opening facing towards the build plate, and then I'm going to generate support. So what you're going to see is after I click on the generate support, what you're going to see is down on the bottom, there are all these support structures. And what this does is this gives us a little bit of an air hole where the air can travel through to minimize the amount of cupping force. So this is one strategy for dealing with cupping. If you find that you really need this lip and not to have support structure on the inside of this model, or to minimize the support structure on the inside of the model, another thing you can do is, what I would recommend is by tilting the model so that it is sort of on an angle, and you want to minimize, you see the orange section down here. The orange section down here indicates the cupping force, and so you want to minimize that as much as possible. And so this will really minimize it, and then print it along this angle. Because of the way that the Form 4L is designed, where above the LPU there's those valleys and dimples in the LPU, which creates the air channel, so to minimize the tear force, some of the geometry, some of the cupping forces can be mitigated. I would compare this to something like the previous generation, the Form 3L. The cupping force, this machine can handle cupping force much better due to the sort of the bumpy textured surface just above the LPU. So you can get away with some cupping force here. Yeah, so that's it in terms of best practices when it comes to slicing. Mainly it's about creating support structures in places that are not critical, avoiding cupping forces by orientation and by creating support. The last thing I'll talk about in preform best practices. You can see here I brought back in the Captain America statue as my sort of sample demo here. Now this statue is solid. So right now, even as it is without any support, you can see that it just exceeds about 1 liter's worth of resin, which is a lot of resin to use up. Now for something like a sort of aesthetic piece like this, where more or less you're looking at the features of the model, you can hollow it out. So this is where the new features that in preform will benefit. So here you're going to see wall thickness. We can change the wall thickness. What it does is it makes this model have a wall of 2.5 millimeters, and we're going to hollow that out right now. Great. So now that it's hollowed, you can see how significant of a drop in the material usage. So we went from 1 liter down to about a quarter of the consumption, which is like 240 milliliters as an estimate. So one other thing you have to do after you've hollowed out the model, because internally what you're going to see is, you see this orange sort of coloring, that is all the cupping forces. So that is going to create some issues for us. And the next thing to do, what we're going to do is on the bottom, we're going to put a couple of holes. Okay, so this is going to help alleviate some of the cupping forces because we just hollowed out the model. And we want to do this as we go up, move up in this model like so, okay? And we're going to apply these edits. And once the edits are applied, what you're going to see is, what we're hoping for here in the print validation is that these will either turn yellow or green, which makes them acceptable. Okay. Almost there. Great. So you're going to see at this point, we're actually ready to put in supports. I'm going to tilt this on its back a little bit. Kind of like before what we talked about, we're trying to look for a surface that's going to minimize the cross-sectional surface area, which is what I'm trying to do here. This should be pretty good. And I'm going to auto-generate support here. And once the support is generated, we should be good to go. This will increase, so the whole process is to minimize the material consumption. We're gonna, once we hollow out the part, we are going to have to put in the drain holes, so the air and the resin has somewhere to go during the print process. The next thing is we have to re-strengthen the part during the print process by generating the supports. Okay, so those are the recommendations I have when we're printing parts like this. Okay. So in preform now, all the supports are generated, the model's hollowed out, and the drain holes are added in. This is what the final sort of print is going to look like before I send it off to the printer. You can sort of take a look at the cross section over here. We have minimal cross section. There are now supports on the inside as well. There is a little bit of cupping that's being detected by the system. You can see a little bit down here and also a little bit over here. These are, I would say, minimal. They're more cautious, but likely not going to cause any type of critical failure. Yeah, so at this point, I would say it's ready to go. And I can just hit print now, confirm, and upload the printer, and we'll be ready to go. Next, I'm going to talk about, once the print is complete, how to take the print off, and what are some of the best practices in terms of post-processing the print, so to achieve the best result. The next part of this, I've asked Aaliyah to help me out for this section of the demonstration, because on the Form 4L, we're given a large height between the surface of the build plate and the bottom of the resin tank that allows you to print, and sometimes the part is going to sit just below the lip of the resin tank. And in those instances, what we're going to do is we're going to need 2 people to remove the build plate as well as the resin tank out. So what I'm going to do is release the wiper first, unlatch the resin tank, and Aaliyah is going to release the build plate, and we're going to move out together, right? Yep. And then Aaliyah can take the build plate off to post-processing, whether it's form wash or form cure. So that is the demonstration for large prints on the Form 4L. We talked a little bit about best practice on how to set up your Form 4L for printing. We talked about some of the key features on preform to help you out during the slicing process and things to look for. And we've also just talked about how to remove really large objects out of the Form 4L. And I have one last recommendation for you when it comes to handling Form 4L prints. What you want to do is, once the print is complete and there is support structure that you have to remove on the part, you want to remove the support structure right after washing it, because at that time the material is still somewhat elastic and easy to remove because there's a little bit of give and flexibility there with the support structure. That will be the most opportune time to remove the support without causing any type of visible damage to the surface during the support removal. If it's done after curing, the resin is going to be much more rigid and much more sort of consolidated, so it's going to be harder to remove the support structure post-curing. You want to do it just after wash, but before curing. The other recommendation I have is, once you have taken the support structure off and it's done washing, you want to let that print sit a little while in ambient environment, room temperature. Just let it sit for the next 6-7 hours to allow the alcohol to dry up, or whatever solution you're using, to allow it to dry up so that it doesn't interfere with the curing process. Okay? So, thank you guys for joining me for this talk on best practices. I hope that I've provided you with some good information for you to have some successful prints on the new Form 4L.
Hi everyone, welcome back. So we have a couple of frequently asked questions on Form 4L, and let's talk about them. So Michael, my first question is, what are the advantages out there for Form 4L besides being able to print larger parts?
Yep. So thanks to the larger build plate of the Form 4L, you're able to fit more small to medium-sized objects on it. This means that less human interaction is needed, as you're able to produce more parts per print run. So Pooja, a question for you. What's the compatibility of resins and consumables with the Form 4L?
So the resins are same as Form 4, but there is an exclusive for resin build platform and the resin tanks. My next question is, what's faster? Is it Form 4 or Form 4L?
So the Form 4 is slightly faster. The larger parts of the Form 4L means that it can't reach quite the same speeds. On the other hand, the Form 4L might give you a faster time per part, as you're able to fit more parts onto the build platform. Pooja, another question for you. How much bigger is the Form 4L compared to the other Formlabs printer, SLA printers?
Yeah, so Form 4L is 4.6 times bigger than Form 4L and 1.2 times bigger than Form 3L printer.
Okay.
So the next question is, are there any new cure and wash stations for the Form 4L?
Yeah, so the Form 4L will use the same cure station, the Cure L, as the Form 3L. Much like the Form 4, the old Wash L is compatible with the Form 4L. However, in this case, you will need an upgrade kit in order to make the Wash L compatible with the Form 4L due to that bigger build platform. What is the warranty on the Form 4L?
Okay, so Form 4L also has 1-year warranty, which is from the Formlabs itself. But if you need an extended warranty, you can use the extended warranty, or also called as the Pro Service Plan, which can be up till 3 years.
Okay.
And the last question that we frequently been asked is like, whom do the customer contact when they purchase the Formlab printer? Is it like Formlabs or Shop3D?
Yep, so if anything should go wrong, you can contact us at shop3d.ca and we'll be able to take care of you. That's all the questions we have today. Next, we'll send it to Ken to wrap things up.
I hope you found all of the speakers for our webinar insightful today. If you're interested in your own Form 4L, make sure you contact our sales team because there's actually an incentive going on till the end of the year. There's a loyalty upgrade, so if you have an older Form 2, Form 3, Form 3L, or even if you just got a new Form 4 and are looking to upgrade to the Form 4L, now is the time where you can save almost $3,000 off consumables for your new printer. So make sure you contact us to get this incentive. Best of all, you don't have to return your older printer to us. That's going to stay in your fleet to keep producing prints. So there you have it. Thanks for joining us for this webinar. My name is Ken from shop3d.ca, and contact us if you want to talk about your application directly.